Algebra 2, Chapter 11 review, question number 103 states, describe the pattern in the sequence and then find the next three terms. Okay, so we look, and hopefully just by observation, by inspection, we can see we are just adding 2 every term. The next three terms would be 21, 23, 25. So the correct answer for this would be D. 104. Write an explicit formula for the sequence 7, 2, -3, -8. So the first thing we got to do is find out if it's geometric or arithmetic. So find the difference between the second term and the first term. So that'd be 7 minus 2. Sorry. Second term and first term would be 2 and 7. So their difference would be -5. So now just double check the third term and the second term. -3 and 2, their difference would be -5. Since there's a common difference, this is arithmetic, and we'll use the formula of A of n, the current term, equals A1, our first term, plus D, our common difference, times n minus 1. Okay, so there's our base shell for the explicit formula. Now let's plug in what we know. A of n equals, well, what's our first term of this sequence? 7. So we're going to plug that in. A of 1 is 7 plus, what was our common difference? -5. -5 times n minus 1. Okay, we're not done writing the explicit formula yet. Now let's distribute the -5. So we're going to get A of n equals 7 plus -5n. -5 times -1 is 5 plus 5. So sum like terms, so A of n equals 12 minus 5n. And you can tell up above they wrote it this way. A of n equals -5n plus 12. So there's our explicit formula. So that's the first part. So we've got it narrowed down to A or C. Then it says A of 14. So what we're really saying is find the 14th term, or our n value is 14. So A of 14 would be 12. Sorry, let's use their formula. -5 times 14 plus 12. So A of 14 would be, that's -70. -70 plus 12. So A of 14 would be 58. -58. So the answer would be C. 105. Is the sequence arithmetic? All we got to do is see if there's a common difference. So let's see if we can speed it up. Second term minus first term is 7. Third term minus second term is 7. Fourth term minus third term is 7. So yes, there's a pattern, and we're going up by 7 every time. So the answer is A. 106, same question. 21 minus 7, or sorry, 21 minus 14 is 7. 42 minus 21 is 21. So we can stop there. It's a geometric, not an arithmetic sequence. So no, there is no common difference. 107. Find the 50th term of this sequence. Okay, just like the previous problem, we've got to find out if it's arithmetic first. And we can find a common difference of -7, -7, -7. So it's arithmetic. So our first term, A of 1, is 5. Our common difference is -7. Our explicit formula, if you remember, is A of n equals A1 plus D times n minus 1. Again, this is arithmetic. Okay, it doesn't say write the formula. It just says find the 50th term. So our n value is 50. So we're just going to plug it all in. So the A of 50 equals A1, which is 5, plus our D value, which is -7, times n minus 1, so 50 minus 1. So our answer is going to be 5 plus negative 7 times 49. Okay, so negative 7 times 49 would be 5 plus negative 343, which if you add those together would be negative 338. So my 50th term is negative 338. So the answer is C. 108. Find the missing term of the arithmetic sequence. Okay, that tells us the missing term is just the average. So 22 plus 34 over 2 is our answer. So that'd be 56 over 2, which would be 28. Our answer is C. 109. Is it geometric? If so, find the common ratio. 109. Well, since we're going to check geometric, we're going to divide them. So a of 2 divided by a of 1 is the same thing as 12 divided by 6, so it's 2. Let's go third term and second term, see if there's a common ratio there. Third term is 24, second term is 12, so that has a common ratio of 2. Again, we're using the word ratio because we're multiplying and dividing. Let's just check the last term. A of 4 over a of 3, 48 over 24, which is 2. So it's the same term every time, so yes, common ratio of 2. 111. I guess I got to do 110 on the same page. Okay. 2, negative 4, negative 16, negative 36. So negative 4 over 2 is negative 2. Negative 16 over negative 4 is 4. So there is not a common ratio. The answer is D. Okay, 111. Write the explicit formula for the sequence. Find the fifth term. Okay, a lot of kids on the test last go around ask, well, what is it? Well, since there's an R value given, it's got to be a geometric sequence. So for geometric, a of n equals a1 times r to the n minus 1 power. So it says write the formula and then find the fifth term. So let's just plug in values. A of n, and again, we're solving for n, equals a1, which is 3, times, I'm going to go ahead and put in parentheses, negative 3 to the n minus 1 power. Now it says find to the fifth term. So I rewrote it. A of 5 equals 3 times negative 3 to the 5 minus 1 power, which is 3 times negative 3 to the 4th power. Negative 3 to the 4th power is 81. Remember, negatives to an even index or an even power is going to be at a positive number. So it's going to be 3 times 81. 3 times 81 is 243. So I'm looking for 243. So there and there. And I'm looking for 3 times negative 3 to the n minus 1 power. There. My answer is A. 112, find the missing term. Okay, well, geometric terms, to find the mean of a geometric term, the missing term, or we'll call it a of n, is the square root of the previous, the square root of the product of the previous number and the next number. So it's just going to be the square root of the product of those numbers. So I'm going to get my handy dandy calculator out, and hopefully it'll show up on the screen. There we go. Turn them on. We're going to hit the square root of 45 times 1620. Make sure you close the parentheses. It's this easy. Hit enter. 270. Easy calculator work. Biggest term is geometric sequence. 113. The sequence has 11 terms. Evaluate the related series. So that means sum them. That means sum them. So let's see if we have a common difference or a common ratio. Again, to find that, you just find the difference of the terms. So it's a common ratio of 6, or common difference of 6. So it's arithmetic. So the equation for the sum of arithmetic series is S of n equals n over 2 times a1 plus a of n. So it tells us our n value is 11, our first term was 15, our last term was 75. So we have everything we need. So the S of 11 equals 11 over 2 times 15 plus 75. So that's going to be 11 over 2 times 90, which is going to be 11 times 45, which that should be 495. Our answer is B. 114. Use summation notation to write the series 49 plus 54 plus 59 for 14 terms. So the first thing we got to figure out, is this arithmetic or is this geometric? So we look for the common differences. Okay, so we know 54 minus 49 from the second term minus first term is 5. 59 minus 54, third term minus second term is 5. So we find out it is a arithmetic mean or arithmetic sequence. So we're going to use explicit formula to get the terms. So a of n equals a1 plus d times n minus 1. So a of n equals, well, our first term is 49, plus, well, our common difference is 5, times n minus 1. So we're going to distribute the 5. We're going to get a of n equals 49 plus 5n minus 5. Sum like terms, so we get a of n equals 44 plus 5n. So for summation notation, this is needed. We need the explicit form. You see it matches 2 terms. Okay, well it says for 14 terms. So we know there's 14 terms we're evaluating. It does not tell us where to start, so we always assume we start with 1 if it doesn't tell us. So we start with n equals 1, and then it goes up to 14, and then we put our explicit formula in front. So the answer is C. Okay, next problem. For the sequence, or for the series, summation of n equals 1 to 8 of 4n, find the number of terms in the series. Well, that's easy. Upper limit minus lower limit plus 1. So it would be 8 terms. So the answer would be C. 116. Evaluate the series. Okay, well this is a arithmetic series, so to evaluate the series is code word for sum it. So the sum is n over 2, first term plus the nth term. Okay, well it tells us our n value is 4. So to find our first term, all we have to do is plug in our n value and solve. So it'd be 1 plus 4, which equals 5. So that's my lower one, that's A1. And to find my upper one, go to the top number and just plug it in. So that's 4. So that'd be 4 plus 4 equals 8. So I have the A1 value of 5 and the AN value of 8. So the S of 4 terms is 4 over 2, 5 plus 8. So 4 over 2 simplifies to 2. 5 plus 8 simplifies to 13. So 2 times 13 is 26. So the answer would be A. 117. Does the infinite geometric series diverge or converge? Well, converge means it comes to 0. Diverge means it does not. So the first thing we got to do is find our R value, our ratio. So second term over first term is 3. Let's just double check that. Third term over second term is 3. Well, since my R value is greater than 1, it must diverge. It's exponential growth. So it diverges does not have a sum. A diverge does not have a sum. So the answer is C. Last question. Evaluate the infinite geometric series round to the nearest hundredth if necessary. Well, our R value is 4 over 8. Second term over first term, which simplifies to 1/2. It has ellipsis. It tells us it's infinite. Since our R value is less than 1, it does have a sum. So the sum of an infinite geometric series is A1 over 1 minus R. Well, our first term is 8, then 1 minus 1/2. So that's going to be 8 over 1/2, which would equal 16. So the answer would be A or C.